Hello everyone. So today we're going to discuss a topic called measures of dispersion. All right. In the last video, we looked into something known as averages, uh, and having discussed how averages work and a common flaw being one value influencing the average. So it is very important to see how far the total data is spread. To do so, we have a few other measures which we're going to look into today in this video, known as the range, the standard deviation, and the variance, and the coefficient of variance. Okay, so let's first get into the concept known as range. What is range, right? It is simply the difference between the largest and the smallest value in a data set. Okay. Basically, it is based on the idea that the spread of a data set can be represented how? By the difference between the extreme values given in a set. But it is, however, very much necessary that the range could have some limitations. It's very sensitive to the outliers, as a single extreme value can greatly affect one particular range. It doesn't take into account like the distribution of values within the data set. So it's not suitable for comparing the spread of data sets with different units or scales. Okay. So now, when you talk about finding the range of grouped data, it is the uppermost interval minus the lowest interval, which is the simplest formula. But when you talk about your ungrouped data, it is your highest value minus your lowest value plus 1. All right. So in this case, if you have to find out, if this is your example, a doctor earned the following fees from his patients in the month of July. This is the set. You basically have to find out the range. Now the formula for range is highest minus the lowest plus 1. So what is the highest value here? 2250, right? 2250 plus, minus, what is your lowest value in the set? 500. So you reduce 500 and then you add a 1 to it as per your formula. So your answer comes up to be 1751, which is the range of this particular data set. Now, this is all about range. Now let's talk about the concept called as standard deviation and variance. All right. So what is standard deviation? Standard deviation, basically, it measures the square root of the variance, okay, representing the average distance between each data point and the mean. It is based on the idea that the spread of a particular data set can be presented how? By the average distance between each data point and the mean. Okay, so if you look at the formula, it is a summation of x minus x bar, that is your mean, the whole square upon the number of values. But this particular formula is only for complex calculations. The most commonly used formula is the frequency distribution formula, which looks something like this. If you see this symbol, this is the symbol for standard deviation. All right. And then when you have to calculate variance, so variance is nothing but just the square of the standard deviation that you've calculated, which is commonly asked along with standard deviation, because it's nothing, because you find out the standard deviation and you just square it up, so you get your variance. So it could be, like a 2-marker, where you have to pick 2 options, which gives you 2 marks in the MCQ format of the paper. But focusing on the theory aspect of variance, it is basically based on an idea that the spread, which is the spread of the data set, it can be represented by the average square difference between each data point and the mean. So it takes into account what the distribution of the values within the data set, and it is very much less sensitive to outliers than what we looked at, range. However, variance can be sensitive to the unit of measurement, which can make it very difficult to compare variances across data sets with different units, because variance is not very easily interpretable, right? It represents the average square difference rather than a direct measure of speed, due to which it is not, it's not something you can interpret easily. Okay. Whereas if you talk about standard deviation, it is less sensitive to outliers than the range, but it does take into account the distribution of values within the data set. So it is very easily interpretable as compared to variance, as it represents a direct measure of spread, and it can be used to compare the spread of data sets with different units or scales. Okay. So these are the formulas. There's an example here. This particular example was the example that we used for mean, right? So these are the outputs and the number of time, the number of days for which this output has occurred. So your F column. Now you have to find out what the standard deviation is and what your variance is. You have to calculate these two. Let's understand. When you look at the formula of standard deviation, including your frequency distribution, you need something called your x square. You need your summation F. You need something called your F into X summation. And then you need summation of F into X square. So you have your data available. You just have to segregate this into the parts of the formula. So let's first find out X square. What is X square? 5 into 5. That is your X square. So same thing would happen for all of them, correct? Then you need something known as your F into your X square, as asked in the numerator of your formula. So you do that. And then you want your Fx, normal F into X. Okay. Now, according to your formula, you require the sum of Fx square. So let's take the sum of this, which is 100 plus 525 plus 270 plus 110. It gives you 1005. You need the summation of F as required by your denominator. So let's get that. Sum of 4 plus 15 plus 6 plus 2, which is 27, right? Then then you need your summation F. You need summation Fx, right? So sum of all of this, correct? Now so sorry for the issue. So we've calculated all the values. Now let's put all of this into our formula. All right. Now let's put all of this into our formula. All right. All the values that we've calculated so far. First, let's break the formula into parts so that we avoid any kind of mistakes. So let's look at the first part of the formula. It says summation of Fx square, which is this divide by summation of F, which is this. You got this part? All right. You just get this to, you can just round it up. So the first part of your formula. Now let's find out this particular part of your formula here. Okay. Or we could do it here. Is equal to, you need summation of Fx. Summation of Fx, which is 201. Divide by summation of F, which is 27. The whole square, so you square it up. Again, you have to round this up. Correct? Now there's a minus sign, so you find the difference out. 58 minus 55. And now you need the square root of this. So square root of this. So your answer comes out to be, round this up to 2 decimal place, which is 1.57. Okay. So this is your answer for standard deviation. Now, if you have to find out variance, okay, your answer simply would be variance is what? The square of standard deviation. So the standard deviation that you got raised to 2. And again, you get this back to your 1 decimal place. So if you see, this particular amount was your variance itself. You square rooted this, so you got standard deviation, and then you go back to variance. So these are the 2 answers that you were asked. Is that very simple? All right. Now let's get into the topic of coefficient of variation. All right. Now, what does it mean, or what does it measure? It measures the relative variability of a data set by dividing the standard deviation, this is the sign of standard deviation, by the arithmetic mean, which is your x bar. But just always remember, this will always be in percentage terms and not in a normal general number terms. All right. So basically, coefficient of variation is based on the idea that the relative variability of a data set can be represented by the ratio of standard deviation to the mean. Okay. It allows for comparison of variability across data sets with different units with different scales. It also provides relative measures of variability across across all the data sets, which can be much more meaningful than the absolute measure, like your standard deviation. And it can be used to identify data sets with high or low relative variability. Okay. So if you have to calculate coefficient of variation, so this is your formula. Now let's look into an example. A company has operation in 2 cities and have obtained the following statistics on the basic weekly wages of its labor. 2 cities given, Sydney and Melbourne. What you have to find out is which city has a wider spread. Okay, so whichever city's percentage would be higher, whichever city's spread would be wider, would be the one which is recommended. So let's look into Sydney first. Okay, so your formula is what? Standard deviation upon your mean. So standard deviation 60 divided by your mean, which is 100, which gives you a 0.6. So if you convert this to percentage, it is a 60%. And then when you talk about Melbourne, okay, Melbourne has a standard deviation of 55 and your mean is 70. So your percentage terms would be 79%. So here we can clearly see that Melbourne has a higher variation in weekly wages for the company. So this is the one which has wider spread. You could write Melbourne has a wider spread. Okay. So let's summarize whatever we have done today. Okay. So range. Okay. Range was a simple measure of dispersion that we did, but it's very sensitive to outliers, so it doesn't account for distribution of values. Variance, on the other hand, it measures the average square difference between each data point, right? And also the mean, but it's very sensitive to the unit of measurement, and which makes it not very easy to interpret. Standard deviation, on the other hand, is easy to interpret because it is more robust. It is the representation of the average distance between each data point and the mean, and the coefficient of variation, which is denoted as the letter R. Okay, provides a relative measure of variability, allowing for comparison across data sets with different units or with different type of scales. Okay, so if you have any specific questions about these concepts, or you would like me to elaborate on any of these points, you could always comment below. Thank you so much for watching my video. Please stay tuned for further videos.